very much. תודה רבה, זה מאוד מעניין. תקראו את האותיות הקטנות, חברים.
כן.
Can I just close the laptop or?
Yeah. Hold on. Take this.
Can you hear me now? Yeah? No, it was close.
Let me put this one on.
Of course.
This is for the recording. So, for those who don't know, Danilo is leading the evangelism for serverless. It's lots of years of experience. And he's going to do some live demo and talk about the serverless. Thank you very much for joining us, Danilo.
Thank you so much for inviting me, Shimon. Thank you. Thank you for giving me this Madonna mic. I'm Italian, so if I can't move my hands when I speak, it's difficult to express myself. So when I was invited, it was difficult to choose which best practices to share. So I decided to focus on infrastructure as code and the new tools that we released in that area. So as Shimon said, I'm quite passionate about serverless. I also wrote a book that has been translated to Chinese and Korean. If I knew beforehand that it was Shimon's birthday, I would have brought the Chinese version for him. It's the only one that I have left. But unfortunately, I realized that just too late. I also work with my publisher to have a free ebook. So the last one here, Agile Development for Serverless Platform, is a free ebook that gives you an overview of the underlying technology to set up an agile serverless development team. And the idea is when you start creating Lambda function, and from what I saw from the other presentation, is quite a team here. If you start to have 5, 10 functions, having to manage those in the console is probably not the best way. So our suggestion has always been, even before serverless, describe what you're building, your architecture, your infrastructure in a text file, and then use that text file with AWS to implement what you want to do. Then this text file, this template can be versioned. You can apply the best practice of software development to it. And we also always add a service to do that. It's CloudFormation. It has been released lots of years ago, but CloudFormation was not very good for serverless. So I think you already heard that we launched a couple of years ago the serverless application model, and it's an extension of CloudFormation. Now we can say that it's actually a macro because we launched publicly CloudFormation macros a few weeks ago. So macros is a way to take a template that you give in input, pre-process it, and then give in output a traditional CloudFormation template. So this is what we actually do, and the translator is actually open source, so you can see it in the same repository. And now you can also add your own translator using your own macros. I was talking with a customer, we had an idea and built like a macro to extend all the templates that they use without having to change them. And it's released with an Apache 2 license, so if everybody in the community needs some way to represent a serverless application, it's there to be used. This is the URL on GitHub. Probably today is not the best day for GitHub, but apart that, it's there. And this is the prototype of a template. So here I'm using the YAML syntax, it's the most common now. And you can define a function with a list of properties, and then you can link the event. In this case, this is an API with a certain path and specific HTTP methods, any if you want to respond to any HTTP methods. And those 2 lines at the beginning here, they say that this is a serverless application model. And this is the syntax of macros. So now you can also add other things there. You link a macro to a Lambda function that will pre-process it. And there are a few like this that are fully managed by us, by AWS. And this simple template will create all the underlying resources that you need. So to create just a Lambda function, you need a role needs a policy, you need an API gateway with at least a stage, a deployment into that stage, you need permissions for the Lambda functions, and so on. This is the equivalent CloudFormation template if you were to use the traditional CloudFormation syntax. So that's the reason why we introduced SAM, because CloudFormation was a little bit too verbose for this kind of scenario. And more recently, to make it easier to play with this technology, we launched the new CLI, and that's what this is the core. So you can really use SAM and start creating serverless function very easily. So the SAM CLI is a CLI that gives you a few commands. So you can validate a template, and this is done using the open source translator. So it's the same code that runs on AWS. You can initialize a new function, a new project. So it's very easy to use. You can package and deploy your application. You can now also tail the logs. So if you want to tail the logs from CloudWatch logs, you can do that from the CLI. I will do a quick demo. And then you can run things locally. So locally, you can generate event. So this will create the syntax of an event coming from S3 or from the API gateway, for example, so that you don't need to remember the syntax by heart. This is very useful to create unit test, for example. You want to say, test what happens if something arrives to your Lambda function. These are the synthetic events that you can generate. You can invoke a function locally. You can start a local emulation of the API gateway linked to the functions. And if you want, you can also start a local Lambda service. This is pretty new, so it will enable on localhost the interface of the Lambda service. So if you use the Lambda invoke API, for example, so you don't go through the API gateway, you can test it. So if you use start Lambda, you can, for example, set the endpoint of the AWS SDK of any application to localhost for the Lambda service, and then you can run locally and emulate the Lambda service locally. So this is where you can find the SAM CLI. We rewrote the first version that we released that was written in Node.js completely from scratch. Now it's written in Python, and you can install it with pip install. And it's using Docker containers under the hood, so it runs where you can use Docker containers on a Mac, on a Linux machine, on a Windows, because the Lambda function will be executed locally on these Docker containers. And this is a script, but I will just do a live demo, so let's not spend too much here. The important part is these two commands here. So when you create something with SAM, the nice part is that then you can run the package and deploy commands. The package command will take the local template and your code and upload it to Amazon S3 in the bucket that you specify. And then the deploy command will take this and implement the application into a CloudFormation stack. And you can iterate these two commands. There's nothing to change for any update. If you run this command again and again, every time you update your code or you update your infrastructure, you will just update your architecture in the cloud. This is very important because the speed of this loop usually is the speed of development. So how quickly you can deploy and start getting a feedback with the new version of your application is critical for the speed of how much you can develop a new application for your users. So on this topic, what we got from our customer is that deploying in production is not always the best experience. Specifically, when you deploy, you want to be able to control and do maybe a control at a small deployment, and then it grows to all your users. So we introduced a few features to do that. So instead of doing the deployment all at once, you can now do traffic shifting and send users to different versions of your application. And you can use also code deploy to do canary or linear deployment in a fully managed way. Just to give a little bit of context, with Lambda, since day 0, we have these two features. So the possibility to have multiple versions of a function, and those are immutable versions. So you have version 1, version 2, version 3, and you can create those versions explicitly when you do an update. So it's not automatic. You have to say, with this update, I want to create a new version. And then we have aliases. Aliases are pointer to a specific version. So for example, the alias live links to version 5 of my function. And then if you create version 6, if you use the alias in the configuration of your application, so for example, the API gateway or whatever application you build in is linking the alias live for your function. If you change the alias, automatically you move the version 6 in production all at once. This was there from day 0 of Lambda. What we added last year is the possibility to do balancing and add weights and say, I want the alias live to send 95% of the invocation to version 6 and just 5% to the new version that I want to test in production. Test in production is an interesting concept, but it's actually what is happening to be sure that it works before I roll out to everybody. And to make this is still a manual process because you need to change the weights. So if you have, for example, a complex application, it's probably not the best experience to do by hand all these changes. So we integrated this deployment with Code Deploy. Code Deploy is the tool that normally you can use to deploy to virtual servers or to containers. Now it can also manage Lambda functions. And it's integrated with SAM. So if we take this SAM template, this is similar to the template that I was showing before. I'm creating a function. I can just add these lines here to say auto-publish the new versions of my application. So whenever I redeploy this function to the alias live. Live is just a name. You can use prod or whatever you want. And then you can specify a deployment preference. So for example, canary 10%, 10 minutes. This means that when I deploy a new version, for the first 10 minutes, it will be visible only to 10% of the users, actually to 10% of the invocations. Those are spread across users. And then after 10 minutes, it's rolled out to everybody. And you can, I'm using globals, so that means that this is applied to every function. If you want, you can specify function by function. This is the name of the alias and the deployment preference. And optionally, you can add hooks and alarms. And alarms are CloudWatch alarms. So if you specify CloudWatch alarms here, if those alarms are fired during the deployment, so during the 10 minutes of canary release, this will be automatically rolled back. So you can set, for example, the latency of the API here. If the latency grows above 20 seconds, I don't know, 10 seconds, depends on your API and what language are you using, then roll back the deployment. And you can use also use custom metrics and custom alarms. So for example, my suggestion is here, don't use only infrastructure metrics, but think of a business metric that is important for you, for your application. And if this business metric is impacted by the deployment, probably something is broken and you should roll back automatically. The example that I always give is Netflix. They monitor the number of play per second. If the number of play per second is affected by a deployment, they understand that it's not that they got new users by the deployment. So something has broken and they roll back immediately and check the logs. So if you have an e-commerce website, check the number of sales per minute, the number of search in the catalog. Try to find 1, 2, maximum 3 top business metrics that you should monitor during deployment. If they get outside of what you expect, probably something is wrong and you should roll back. And if you can create an alarm, you can do that automatically. Hooks are really interesting because hooks are 2 Lambda functions that you can create and write with any logic you want, and they are executed before and after the deployment. So the pre-traffic function is created when the new version of your function is being created, but still no user has ever had access to the function. Then the deployment starts, and you have, for example, the canary or the linear deployment. When all the users have access to the function, so the deployment is completed, then we execute the post-traffic function. And this function can include any check you want, and they can give the succeed or the failure to the deployment based on your own checks. So if you have any control that you want to do on top of the normal controls that we do, you can put them here. The pre-traffic function is also a very good place where you can do something that I will say at low voice, pre-warm your Lambda function. That means that if you're afraid of cold starts, because, for example, you use the VPC, and currently when you connect a Lambda function to the VPC, every time it takes a few seconds to get the network interface, you can call the Lambda function at least once in the pre-traffic function. You can also check that the function works and returns what you expect if you want. And if this works, then you do the rollout. And in this way, we already pre-provision a container with a Lambda function with this new version before it's released to your users. If you expect a lot of load from the users, you can also call the Lambda function in parallel. So let's say that I expect that I need 100 concurrent Lambda functions because I have lots of users. When you release a new version, we start from scratch, so we need to create all those the containers. If in the pre-traffic function, for example, for 20 seconds, you call the Lambda function with a high parallelism, we start provisioning these containers, and then you start the deployment, and they found already a, let's say, pre-warmed environment. This is a hack. It's something that we are trying to optimize so that in the future you don't need to do this. But for now, if you are affected by cold start, you can ask us, but this is a way you can manage that. And then from the code deploy console, you can control also visually the deployment. You can roll back. You can stop the deployment with or without rollback. This is not the latest snapshot because we just recently updated the code deploy console, but it's pretty similar to what you get now. So let's see how this works live. And I want just to give you an overview of the new SAM CLI. So this is the SAM CLI. And let's create with same init a new application. I can choose any runtime. So let's use Node.js. This is one of the most common one. And let's call it Node app. And now this has created a Node app directory. If I go in an editor, I can see that I have the Node app directory with a template and some source code. So if I click on template, you see that we already prepared the template with all the configuration. We assume Node.js 8.10, the last version here, with the output of the API. This is creating an API under /hello. So you have all the syntax here that you would need to create. Here we also have some tests. So I think we use chai for Node.js, but for every runtime we set up some best practice on how you should set up unit testing for your Lambda functions that you can run in your build environment. At this point, we can, for example, go, and also some dependencies. So for all the runtimes, we show, even if it's not required, how to manage dependencies. So in this case, I think we include in the Lambda function Axios for managing external HTTP requests. And we show how you need to manage. In this case, it's easy. You have the package JSON and how to package that and upload that with your Lambda function. So if I go here, I can go into the Node app. I go into the hello world. Here I can do npm install. And this is downloading half of the internet as usual. Okay, 34 packages to install Axios. Interesting. And then now I can do npm test. And this is using chai to running test. And if you want, you can go here into the test directory and add more tests. This is for unit test. And this is just an example of how you can add the unit test for a Lambda function. You can add more. In this case, you're expecting hello world, nothing strange. And now that I have the function completed, I can use, again, SAM local now to emulate the API gateway. I can do SAM local start API. And now my function is answering under /hello on localhost. I can go here. And let's zoom a little bit. And if we look here, we see that now I'm checking the Docker container. Hopefully the container is already downloaded on my notebook, so I don't need to download it. And then we executed the function, and we have hello world from my IP address. That's the hello world application is checking your IP and doing hello world. And if I want, I can go, can I now deploy this? So I can do SAM deploy. I have to pass the template, SAM package, sorry. the template file is template.yaml, and then I use an S3 bucket to upload it. I have one that I created, is Danilo packages, and then I have to say which is the output template file. This is where I write the output of the template, package.yaml, for example, output. And the package YAML template is equal to the source template, but in the original template, there is a link to to the source file as they are local. So if I in the package template, there is a link, the link to S3. That's the only difference between the two templates. And now I can do some deploy of this template file. So this is package.yaml. And I have to give a stack name. Yeah, thank you. The stack name, let's call it node app. And do you think this works? There is one thing missing. A few seconds before we get there. No, it will work. It's failing because CloudFormation by default doesn't give you permission to change other permissions, because it's always delicate if you create new roles or create new users. But with serverless, every time you create a function, you need to give some permissions. So you need to give this capability that is not the default, this capability IAM. So the possibility for CloudFormation of creating the roles for the function. This is something that, oops, capabilities, because it's more than one option. So now we are creating the change set. The change set is the comparison of what you want to create compared to what is already there. Now it's a new creation, so there's nothing. And if we go on the Lambda console, we can see if there is something. So if I go on CloudFormation, we should start to see stuff happening.
Why did it offer you to run CloudFormation commands?
Sorry?
Why did it offer you to run CloudFormation commands?
Because actually the SEM package and the SEM deploy commands are a wrapper on the AWS CLI, AWS CloudFormation package and AWS CloudFormation deploy. It's the same syntax. Currently they are a wrapper. We are thinking if we should make it slightly easier to use than the traditional AWS CLI. For example, we had some discussion on the fact that you need to specify an S3 bucket. So some of us wanted to maybe create a default bucket, but then at the end we decided that it could be bad if we create buckets and use a developer that is not familiar with AWS doesn't understand that we are creating a bucket in his behalf. So for now, it's just the same syntax. If you have any idea of what we can make it easier or simpler from a developer perspective compared to the traditional CLI, we are open for suggestion. It's always difficult because when you simplify, sometimes you are doing things under the hood and Magicify. Okay.
How would you compare this version of SAM to serverless framework?
So I think the serverless framework is more more of a scaffolding approach in my perspective. So if you come from tools like Redis or Express, you probably feel more comfortable there. This is completely abstract and separated from the development. Because the template, the only mention of the language for the template is in the runtime. So the template for Node.js, Java, .NET Core, so C# or F# is always the same. So depending on what you prefer, you can use either. To make it a little bit more easier to use, we added to CloudFormation macros. So what I'm starting to see is customers that create macros that on top of SAM can make it further easier to use. So just to give you a quick, so now the Node app is up and running, and I can go on the Lambda console, where we recently added the concept of application. I don't know if you noticed that. So now in the Lambda console on the left, you have applications. And the applications is the list of CloudFormation stacks that have at least one Lambda function. And then we assume this is a serverless application. So here you can see the Node app that I just created. And here you can see the SAM template, and you can also see the resources that have been created. So I can, for example, click here on the function, and straight from there discover the function. I can go on the API gateway and see the endpoint. So this is the endpoint of my hello world function. So now I'm executing the hello world function straight on the cloud. And I can also go back here and see the logical name of my function. This is this one. So if I want, I can now go here and do SAM logs. Let's do an help just to SAM logs. I can say the name of my function is hello world function. It's in the stack Node app, and I want to tail my logs. So now I'm tailing the log of my function. So if in the cloud I execute the function again, you start to see the log appearing here. There's the usual small delay of CloudWatch logs, but it works. So you can, if you are used to having the logs of your application somewhere on your desktop, you can now do that very quickly, or you can still use the CloudWatch logs console. And finally, this works also for other languages. So I can use SAM init runtime Go. Let's use Go to show an environment that needs a build, and the name, let's call it Go app. And if you go here, you see that now I created the Go application. There is now the same function that does hello world with your IP address is here in Go. And here I have now a make file. The make file is making the build, and it's also taking care of the fact that the build must be cross-compiled for Linux. So if you use Go and you compile on a Mac, you would not get the right binary otherwise. So if now you go into the Go app, you can do make build. I already installed the dependency, otherwise you will need to install some dependency the first time. And then you can now do package. So if I take the same package that I just ran, I can just run it. I don't need to change nothing here because it works the same for Node or Go. It's now packaging and updating the new version. It's a little bit bigger, the Go version of the hello world. And then I can do deploy. And now the only thing that I need to change is the stack. Otherwise, I would just update my stack. And now I'm creating the same app in Go. So if I go here in CloudFormation, I see that I'm deploying also the Go application. So if you're looking for best practices of how doing unit testing, how to manage a build for a Go binary, also for Java is the same. So if you use Java, we have an example that automatically is creating the template for using Maven and installing all the dependencies and packaging everything when you upload. So look at this tool because we're trying to put everything here. And if you see that we're missing something, just call us because that's what we like to do. Just one final thing, the serverless application model is actually updating, and in the latest release, we added the possibility to do things like inline functions. So if you go here and see, you can now put, this is a valid SAM template now where I put the inline code of my function to say hello world in a template. So if you create a very small function, it can be a nice trick. And with this, thank you. Any question? Do we have time?
Yeah.
Okay.
So my question is, what are the top 3 bad things, most common mistakes that people do
with serverless? So probably the most common one, or let's say the worst that you can do is creating recursive functions. So a Lambda function that in some way is triggering itself again and again, and then you can really consume your throughput. So you can do that, for example, if you create a function that is triggered by an S3 bucket, and then the same function writes on the same S3 buckets, and you don't realize that it's a different path, but it's still within the scope of the trigger. You can specify a path, but it's a common mistake. There are other ways, but this is probably the most common one. So always try to think that. That's why if you understand that you are firing your function again and again, we added to the Lambda function a button here that is throttle, that you can see here. If you click on this throttle, we'll set the concurrency of this function to 0. That means that all the execution will be freezed. Then you can change the trigger. And then since those throttles will be errors for asynchronous invocations, we will retry this for some time. So you should keep the throttle for like 15, 20 minutes. And then you will maybe still have a few invocations, and then it will stop the recursive loop that you created. I think this is probably the biggest error. Second error that is more on the development side is probably creating too large functions. So there's no right way to find the right balance between having a large function doing multiple things, like if you create an API, maybe the same function doing get and post, and creating lots of small functions. It depends on programming style, but my perception is anytime you can split in smaller components and you don't feel that you need to replicate code too much, do it. A little bit of replication sometimes, even if it's something normally we avoid, can be not as much as bad as having a large code base, then every time you touch something, then you have an effect in another part. Normally, if you start to have separate team working on two Lambda function, if they overlap a little bit, it's better than if they have to tie what they do together and they must release everything together because they share a library, for example. And I think those are probably the top two items. I don't know if that resonates with you and your experience. Yeah?
If I have a service that is provided by a Lambda function and I get attacked, people invoking it multiple times, so I can basically throttle it, but I would lose some of the true requests that I get into the system. How would you replay the information, only the information that you want, or fix or protect from that kind of attack?
Yeah, so generally for any kind of like denial of service attack like this, you either can distinguish who is the attacker, or you need to choose absorb the attack. So I take everything because I can scale, the cost is not a problem. Or I block without knowing who I'm blocking, so I may lose real requests. This is for everything, not just for serverless. In this specific case, if you're using the API gateway as interface, you can create a regional API gateway and put a web application firewall in front of the API gateway, and this gives you more control, because in that case you can block by IP address or by some characteristics of the request that can identify who is the offender. Maybe even if it's a distributed attack, you can still recognize some syntax in the request. And that's a good way to avoid. So if you are building a sensible API and you expect attacks, this is something that I would suggest. And then if you want to throttle, you can throttle at API gateway level or at function level. At API gateway level, you still can throttle based on some characteristics like API keys. So for example, if you give API keys to the users, you can recognize that maybe one API key has been compromised and block that one. If you throttle at Lambda, you're throttling just invocation. So with Lambda, you basically limit the number of concurrent execution environment that we have. And if you have asynchronous requests, we will queue them. So there will be a queue. And if there are synchronous requests that are throttled, they will get a 500 immediately. Did I answer your?
Okay.
Thank you.
Thank you very much. ותגישו מועמדות לספיקרים, תבואו, תרצו ב-AWS Community, זה הולך להיות נבל, יש לו גם טוב מאוד מעניין, אז דברו איתנו ונעזור לנו גם להכין את הרצון.